The lesson objective for this video, students use proportions to identify similar polygons. So first of all, what is similar? Similar means that I have two figures where the corresponding angles are congruent and the corresponding sides are proportional. And the symbol to represent that something is similar is this little tilde or squiggly line. So the angles are congruent, the sides are proportional. So what that means is basically they're going to be the same shape, but they may be a different size. The scale factor for two similar polygons is just the ratio of the lengths of the two corresponding sides. So in example 1, we're told that in the diagram, triangle ABC is similar to triangle DEF. So when they talk about a similarity statement, that's what they're talking about. The statement that says two things are similar. So my angles are congruent, and then my sides have to be proportional. So if I look at my angles, the angles that are congruent, just like with congruent triangles, the vertices are in corresponding order. So angle A would have to be congruent to angle D. Angle B would be congruent to angle E. And angle C would be congruent to angle F. Now my sides aren't congruent, but they're proportional. So side AB corresponds to side DE. So AB over DE, if I look at that ratio, I have 10 over 15, and that reduces to 2 over 3. And if I look at BC over EF, those are corresponding sides. So 8 over 12, that also reduces to 2/3. And then finally I would look at AC and DF. So AC over DF would be 12 over 18. And that also reduces to 2/3. So in a statement of proportionality, any pair of ratio forms a true proportion. So I saw that all of these came out to 2/3. So I can write a statement of proportionality for all three sides. I can say that AB over DE is equal to BC over EF, which is also equal to AC over DF. So any two of those I could take out and say that they would form a true proportion because the ratio of the sides is the same for each of them. All right, so example 2, we're going to determine whether the polygons are similar. So let's move that down so we can see that. There we go. Determine whether the polygons are similar, and if they are, we're going to write a similarity statement and find the scale factor of ABCD to JKLM. So first of all, I look at my angles. I can see that angle A is congruent to angle J because they're both right angles. And angle B is marked as congruent to angle K. Angle C is congruent to angle L. And angle D is congruent to angle M. So I've met the requirement of all the angles being congruent. All the corresponding angles are congruent. So the next thing I have to look at is the sides. And are they proportional? So I'm going to compare AB to JK. I'm going to compare BC to KL. and I will compare CD to LM, and finally I have to compare AD to JM. So if I go back and look at what each of those are, AB is 8, JL, or JK rather, is 14, BC is 8, and KL is 14, CD is 8, LM is 14, and AD is 12, and JM is 21. So if I reduce those, they all reduce to 4/7. And so that means that all my corresponding sides are proportional. So because I have all my corresponding angles congruent and all my corresponding sides proportional, I can now say that I have two similar figures, that A, B, C, D is similar to JK, LM, and the scale factor is 4/7. All right, in example 3, I'm told that triangle BCD is similar to triangle RST, and we're going to find the value of x. So again, I want to look at what's corresponding. CB corresponds to SR, so that would be 12/24, and then 13 corresponds to the x, so that has to equal 13/x. Now I can reduce it before I cross multiply, so 12 goes into that once and into that twice. So when I cross multiply, I have x times 1, or x, and equal 2 times 13, or 26. So the length of side ST would be 26 units. So if two polygons are similar, it turns out that the ratio of the perimeters is the same as the ratio of the sides. So in my diagram, if KLMN is similar to PQRS, then I know KL plus LM plus MN plus NK over PQ plus QR plus RS plus SP is going to equal the ratio of the sides. This represents the perimeter of KLMN, whereas the denominator is the perimeter of PQRS. And the ratio of those perimeters is going to be the same as the ratio of the sides. So it's going to equal KL over PQ. It would equal LM over QR, RS over MN, and KN over PS. All of those are going to be the same ratio. So suppose, I'll throw some numbers up here. Suppose that KN was 2, KL was 6, NM is 8, and LM is 4. And then all I give you for the second figure is that PS is 3. Well, I can use the ratio of the sides to find the perimeter of PQRS. So I can see that Kn corresponds to PS, and therefore 2 to 3 is going to be the same ratio as the perimeters. Well, if I add up 2 plus 6 plus 4 plus 8, that equals 20. So the perimeter of KLMN is 20. And then I want to know the perimeter of PQRS. So now I have a proportion. I can solve it with cross products. I cross multiply, and I get 2p is equal to 60. And so if I divide by 2, I find that the perimeter of PQRS would have to equal 30 units. So here's one for you to try on your own. You're going to find the perimeter of triangle WXY given that the two triangles are similar. So set that one up. Pause the video now. Okay, so the proportion you should have set up is 40 over 72 is equal to P over 216. So I can reduce that before I cross multiply, because 8 goes into 40 5 times and into 72 9 times. Now if I cross multiply, I have 9p is equal to 1080. And so then if you divide both sides by 9, hopefully you got that the perimeter was 120 units. Example 4 states that a large cement court is being poured for a basketball hoop in place of a smaller one. The court will be 20 feet wide and 25 feet long. The old court was similar in shape, but was only 16 feet wide. They want us to find the scale factor of the new court to the old court, and then find the perimeters of the new and old courts. So first of all, I'm going to draw myself a picture to help myself visualize it. So they told me the new court was going to be 20 feet wide and 25 feet long. So I can figure out my perimeter by adding up the sides. Basically I have 20 plus 25 plus 20 plus 25, so that adds up to a perimeter of 90. Now my old court is smaller, and all they told me was that the width was equal to 16. But I don't know the length, so I don't know the perimeter. Alright, so first I'm going to look at the scale factor. The scale factor is just the ratio of the sides. And they want me to do the factor of the new to the old. So that's the order that I will go in. So if I take the corresponding sides, 20 and 16, that's going to give me my scale factor. So it equals 20 over 16, and then that can be reduced to 5 over 4. So the scale factor of the new court to the old court would be 5 to 4. Then for part B, to find the perimeter of the new court and the old court, well, I already found the one for the new court because we just added up the sides for that. But I can use that scale factor of 5 to 4, and it's going to equal the perimeter of the new one, which we said was 90, over the perimeter of the old court. And now I've got a proportion, I can just cross multiply. So 5p is going to equal 4 times 90, or 360. And then if I divide by 5, I get that the perimeter of the old court I get the perimeter of the old court is equal to 72 feet. Turns out that special segments are also proportional, so we can use the scale factor when we're dealing with special segments. So by special segments, I mean medians, altitudes, and so on, angle bisectors, etc. So for example 5 in the diagram, triangle FGH is similar to triangle JGK, and we're going to find the length of the altitude GL. So first of all, let's see which triangles I'm talking about. FGH is the larger triangle, so I'm going to go ahead and move that over here. And then JGK is the smaller triangle, so I'll move that over here. Alright, so labeling those, these are both angle G, but here I've got F and H, and here I have JK. And then I've got their altitudes. So they told me that this segment here was 8, and this segment here was 5, and the altitude, GM, was equal to 14. And this is the one I'm trying to find. So I can set up a proportion using the corresponding parts. So x over 14 is going to equal 8 over 5. So if I cross multiply, I get 5x is equal to 112. If I divide that, I get that x is equal to 22.4. And so the length of GL is 22.4 units. So here's another one for you to try solving on your own. You're going to find the length of the median QS. So set it up and pause the video now. Okay, so you should have set it up 39 over x equals 24 over 16. 24 over 16 could be reduced before you cross multiply, and then you end up getting that x is equal to 26. So the length of the median QS is 26 units. And that concludes this video.